So what I want to talk about today is how to find the measure of central tendency. And a measure of central tendency is an attempt to describe a data set using only one number. So you're trying to represent really the center of this data or the middle of this data. So mean, median, and mode are all three ways that you might try to measure where the center of a data set is. Copy down your target. I can find appropriate measures of central tendency. And you've done these before. So mean is the one that we typically say is the best, and it's what we refer to as the average. Most of the time, the mean is going to be the best representation of a data set. And the way you find it is you add up all the values and divide by how many there are. The median then is the middle term. So what you need to do is put your data values in order. It doesn't matter if they're least to greatest or greatest to least, but I always do lowest to highest, and then find the middle value. Remember, if there are two middle values, you actually have to find the average of those two, which means you would add the two together and divide by how many there are, and divide by 2 to figure out what the middle of those two middle terms are. And then the last one, the third one, is the mode. The mode is the one that occurs the most often, so mode is most. With any data set, you could have maybe no mode if no numbers occur more than the other ones. You could have one mode, you could have multiple modes. So mode is going to be a value that occurs most often. If all the data values occur once, there's no mode. But if all the data values occur once and there's one that occurs 3 times, then that value is the mode. So let's jump right into example 1 because you've calculated these before. The table shows the average distance from each planet is from the sun. Find the mean, median, and the mode. And take a look at the table and notice we're talking about miles and millions. So you need to make sure when you find these values, don't forget to say that this is millions. To find the mean, you can just add them all up and divide by how many there are. So I'm going to have 93 plus 484 plus 141 plus 36 plus 2,796 plus the other ones. Now here's the deal. With the mean, you don't have to have them in order, but you add them up and then divide by how many there are. There's 1, 2, 3, 4, 5, 6, 7, 8 values. 1, 2, 3, 4, 5, 6, 7, 8. Just want to make sure I'm doing the right thing. So pull out your calculator and add these up with me. We have 93, 484, 141, 36, 2796, 887, 1784, and 67. And you do this too because you want to check me and make sure I'm getting it right. So it's 6288 divided by 8. I got this to be 786. Now that's 786 what? That's 786 million. So the mean is 786 million. You really should put that million on there because it's not just 786 miles. It's a million. The median then is the one that's in the middle, so we have to order these data values to get the middle. So we have 36 as our lowest, then 67, then 93. Then I see a 141, 484, 887, and then 1,784 and 2,796. So we have quite the spread here of data. We have an even number of values. So I know I'm not going to have just one number in the middle. I'm going to have multiple. So you can cross them out as you go, one from each end, or you can mark them off maybe with a check above. These two are the middle, so I have to find the average of them. If there was only one value, that would just be your answer. But since there's two, add them up and divide by 2 to find your true middle. So I'm going to have 141 plus 484 divided by 2 and I get 312.5. So it's 312 and 5/10 million. Again, I would put that million on there because it's not just in the 300s, it's million miles. And then the last one is the mode. When we look at this data set, do any of the values occur more often than the other ones? No. Then there's no mode. Like I said, if there were 3 values that occurred twice, all 3 of those could be the mode. If there was 1 value that occurred 5 times, then just that 1 value would be the mode. It has to occur more often than any other one. So let's try another problem. We are not going to do too many that are just basic finding mean, median, mode. Because you've done this before, this isn't your first year learning this. So we really want to take this farther. Lauren has taken 3 tests worth 100 points each. Her scores are 85, 93, and 88. She has 1 test left to take. What score does she need on the 4th test to get an average of 90? You know, as a student, you might be doing this sometimes. What do I need to get here so that I can keep, so I can have an average of an A overall, or so I can keep my grade as an A or a B? This is a good thing that you can use. So we know she's going to take 4 tests, and we want that average to come out to 90. Well, that means I'm going to have 4 test scores being added, and I'm going to divide by 4, and it should total out to 90, right? This is the average, and the average is 90. Well, I know 3 of her test scores, so 85, 93, and 88. Her other test score is what I don't know, so we can throw an X in there. Remember, guys, in algebra, if you don't know something, you can use a variable to represent it. Now, you might be able to solve this without showing a formula, showing an equation. You might be able to kind of guess and check. But to get this down on paper, it'd be really great for you to show me an algebraic equation like we have here. So do this problem with me. Let's simplify this. I can add all 3 of these together. 85, 93, and 88. That's going to be 266 plus X divided by 4 equals 90. To get X by itself, here's my X, I want to isolate it. I need to get the adding 266 away, and I also need to get the dividing by 4 away. Since the dividing is locking this whole numerator in, let's cancel that out first. To cancel out dividing by 4, I could multiply by 4, right? And whatever you do to one side, you do to the other. So by doing this step here, I can cancel the 4's, and now I'm left with just 266 plus X equals 90 times 4 is 360. And now I can solve this by subtraction. So like I said, while you may be able to do this without an equation, this algebraic equation really shows your work down on paper, nice, neat, and organized. So X is representing my 4th test score, and it's going to come out to be 94. Anytime you have a word problem, I like to answer it with a word answer. So she needs a 94 on the 4th test. Please write that down as well. Well, you could have an outlier in a data set. An outlier is a value that is much greater or much less than the others in the data set. You know, those test scores, they were all pretty close together. I would say that all of these are very similar. There's no outlier there. When you go back to these values, though, there's some high values. So, you know, these are much smaller, but this 2,700 is pretty large. Even the 1,700 is pretty large. So some you might want to check, is that last one an outlier? Now, there is an actual outlier formula. We're not going to cover it in pre-algebra, but you can look it up. But we just want to investigate this idea of an outlier. When you have an outlier, it affects some of the measures of central tendency. Let's take a look at a simple example here. Find the mean and the median of 1, 2, 3, and 4. Then find the mean and the median of 1, 2, 3, and 40. And which measure of central tendency best represents the data when there is an outlier and why? I really want you to pause this video here, try this on your own, and then go through and answer this with me and see what I have and see what you have and compare. So go ahead and pause and try example 3 and then press play. So hopefully you've tried example 3. For the mean, when I add those up, I get 10, and 10 over 4 is about 2.5, or is 2.5. And the middle, when I cross them out, the middle of 2 and 3 is 2.5, so that's also my median. But when I change 4 to 40, 40 I would say is much greater than the others in the data set. Now my mean is 46 over 4, which is 11.5, but my median is actually still 2.5. So did you explain which measure of central tendency best represents the data when there's an outlier and why? You can see that when there's an outlier, the mean is really affected. So the median is better when there is an outlier because it is not affected. An outlier affects the mean the most. If the value is much larger, it's going to pull that mean up like we see here. Whereas if the value is much smaller, it's going to pull that mean down from where the center of that data really is. So you may want to go with the median as the best representation if there is an outlier. So make corrections if you need to. Hopefully you have something similar to that written down and you're good. Example 4 then, if 6 friends went to dinner and split the check equally, which measure of central tendency would describe the amount each person paid and explain? Since they're splitting the check equally, would that be the mean, the median, or the mode? Hopefully you're saying the mean. And why is that? You know, when we think about it, when we're splitting a check equally, they calculate the average cost per person, and that really is the mean because we have that average there. So by splitting the check and the number of people, that's just like adding up everybody's bill and dividing by how many people there are. That really is the mean. Excellent job. So this last one here, this challenge question, I want you to try this without me talking you through it, but I gave you a little hint. I don't actually ask you to find what X, Y, and Z are. I just want you to tell me what is the mean of X, Y, and Z. So try this one, and then you can press play to go over it. Okay, so have you had any success with this challenge? When we look at this, it looks intense, but you really don't need to get hung up on solving for X, Y, and Z. You just need to remember the formula. To find the mean of these 3 numbers, I would need to get this equation to be X plus Y plus Z divided by 3. And I want to know what does that equal? Because this expression over here is the mean, right? So if I want to know what is the mean of those 3 numbers, I just need to get this equation down to this. So up here, there's a times 4. I don't want a times 4. What would I do to undo that? Divide by 4. Whatever you do to one side, you do to the other. So those cancel on the left, and now I have X plus Y plus Z divided by 9 equals 2. Well, I don't want it to be divided by 2. I want it to be divided by 3. Let's think, how can we make that 9 become a 3? Well, you may have got this. If I multiply both sides by 3, this is like a 3 over 1, right? I can reduce this 3 and this 9, and that will only leave me a 3 underneath. 3 divided by 9 is 1/3, so it would just be X plus Y plus Z divided by 3, and then that's exactly what I wanted. So whatever I have over here is going to be the mean. 2 times 3 is 6, so what is the mean of X, Y, and Z? The mean is 6. So if you got that, way to go, nice job. When I first looked at this problem, I thought, okay, I got to figure out how I can find X, Y, and Z, but really, you don't need to. You just need to find the mean, and that by manipulating the equation, you get down to what the mean equals. Excellent work here, guys.